Hello, everyone. Welcome to today's webinar with Jeff Walling. My name is Kristen Price, and I am the Product Marketing Manager here at Technical Toolboxes. We will get started here shortly, but first, if you have any questions on anything Jeff is covering or how our API software works, there's a chat box on the right-hand side of your webinar interface. Please feel free to send us questions throughout the presentation and demo, and we will do our best to cover all these questions we receive at the end of the presentation. With that, I will turn it over to Jeff and we will get started. Thank you very much.
All right, hey, thank you guys for joining me today. I've been asked to do a presentation on the kind of the sequence of events in doing an API 510 and 570 inspection. So I put together this PowerPoint, and I got like 15 minutes for the presentation and 15 minutes for the software. So let's get started here. Right now we got the agenda here. We're going to go through some basic API 510, 570 inspection criteria. We're going to look at some damage mechanisms. We're going to look at determining inspection methods, and then we're going to do a live demo for the API toolbox, and then we have some poll questions and some Q&A to go through. So let's get started here. Okay, so the basic API 510, 570 inspection criteria. So the first thing you want to do is kind of put a little plan together. You want to look at determining vessel use and operating conditions. You know, you kind of want to know where, if it's in a corrosive or neutral environment, what corrodants are in the streams that are passing through this vessel, whether or not it's in cyclical service, because that could cause fatigue, temperature, pressure, fill cycles. You want to obtain the manufacturer's U1 data sheet or any other design documents, drawings, as-built, ISOs. Okay, that's very important to get those things up front. Take a look at those, make sure you understand the parameters of this vessel and its use. And of course, you want to preview previous reports so you can identify any previous hotspots. You know, that way when you go into the vessel or get to doing your externals or whatever you're doing, UTs, maybe they had found in the previous inspection a laminated area or something. You want to check that, make sure that they didn't misdiagnose it, and kind of get the data for that. All right, then you want to determine needed inspections, whether it's the externals are due. Externals are due every 5 years for API 510, and depending on what category the pipe falls into, it could be 5 or 10 years or more or less. And you got to determine what the NDE you might need to going into this, especially after having previewed the previous reports. Whether or not an internal is due or needed, you know, you can do an entry. You can do on stream for that, remote camera. You know, depending on accessibility, sometimes they don't even have manway, so you cannot go into. You might go with a remote camera or just do extra UTs externally. All right. So damage mechanisms. Let's just take a real quick look at some of the most common damage mechanisms you can expect in a 510 or 570 inspection. And you can reference API 571 for particulars of corrodants such as susceptible metallurgical zones, weld has, base metal. So, you know, a vessel will have like 3 different metallurgical zones: the weld itself, the has zone, which is within 1 inch of the weld, and then the base metal. They all have slightly different metallurgical elements to it. See if there's any effects in the vapor space, at the liquid line, at the vessel bottom, depending on what kind of service it is. Some of your corrosive components of crude oils and processed fluids. Okay, the most common internal corrodants in refineries are sulfur and chloride compounds. So you have your acids, especially in high temperature sulfur and H2S and naphthalate, especially in refineries. Naphthalate can be really bad stuff. Then you have chlorides and fluorides, you have phenols, and you have caustics. Those are some of the main chemicals that would cause damage to the internal side of the vessel. Look at the damage mechanisms, some of the specific ones. You got low temperature hydrogen embrittlement, hydrogen blistering. And I'm showing API 571, the paragraph references for that. All right. You can have high temperature hydrogen attack. So these are mostly found in your refinery hydrocarbons. Okay. Stress corrosion cracking is a big one. All right. Chlorides in stainless steel. You see this a lot. Okay. Atmospheric corrosion, uncoated steel in moist environments, or CUI, which is corrosion under insulation. You have your erosion and corrosion, largely in piping elbows, small bore piping. You have galvanic corrosion, where there's two different metals in contact with each other. You have crevice corrosion, and especially at piping supports. You have carbon dioxide, that's CO2, especially in steam condensate systems and at the elbows especially. So again, these are some of your corrodants that could affect your equipment. Here you have a sample of chloride stress corrosion cracking in stainless steel. To give you an example of what that would look like, kind of spider cracking, stepwise cracking here. So when you see something like this, and a lot of this stuff you might not see with your eyes, and like here, might have to do a dipenetrate, Mach particle, something like that testing to see it. Here's some other ones that could catch you. Here you see a weld that was welded over top of a previous crack, which you should never do. Okay, you need to do a V-notch into the crack that's existing down to the root and then build it up from there. This one, they did the weld right over top of the crack. And what happened, because it is a high stress point, that's why it cracked to begin with, it cracked again. If you could just barely make it out, there's a crack right through here. Okay, folks, when you weld over a crack, you essentially have a crack, and it just needs a little bit of stress will cause it to propagate. Here you have some acid, such as sulfides or H2S, wash out right here. The weld's gone and washed it out. And stress corrosion cracking. If you can barely see it through here, but there's a lot of cracks right there in the steel itself, stress corrosion cracking. And here you have a crack at the toe of weld due to overstress, just poor design. You can overlook that thinking maybe it's a shadow because it's right at the toe of the weld. Okay, so these are some of the different things you might see in an inspection. You got to really look close at all the welds. You got to look close at even out in the welds for chloride stress corrosion cracking. All right, so the number one method that you want to use is, of course, visual, VT. Okay, visual inspection of internal and external surfaces are preferred, of course, because when you can see it, anything like a dent, a corrosion, cracks, you can instantly identify it, and it's less expensive than getting any other kind of NDE. On-streams can be used in lieu of internal in cases where where there's sufficient inspection history. And in industry standards, you can always refer to them to see, like for instance, LPG tanks of zero corrosion rate. If it's too small for entry or no manway, or a risk-based inspection evaluation has been completed in accordance with API 581. Additionally, remote camera can be used for internal inspections. Insulated components should be interrogated via UT ports, cutting windows for sampling, or damaged areas to verify that there's no CUI damage in the vessel or piping. A checklist should be developed and followed to ensure all items are examined. Relief valves are very important. Some of the biggest catastrophes in our history have been the result of poor relief valves on them. Okay, so you must check those. PSM requires pressure vessels to have data plate on them. So if you're doing this in a PSM environment, it's a pressure vessel. It qualifies as a pressure vessel. It's operating above 15 psi. It's regulated that it should have a data plate on it. Okay, with the parameters on it. NDE exams. Vessels and piping normally will have some form of NDT to check for specific indications. You have ultrasonic thicknesses for just general corrosion, general areas that might see uniform material loss, metal loss. You are going to need to establish CMLs, conditioning monitoring locations, which may have several TMLs within the location. Say you have an area of the shell on the north side, lower bottom, you might want to get 2 or 3 readings. So the area is the CML, the readings themselves, the individual readings are the TMLs. All right. You might need, if you're aware that there's issues with this, there should be some little indicator on the vessel where you can take the readings from the exact same spot, so you can do long-term, short-term corrosion rates. You have areas discovered to have or expected to have wall loss can be averaged over lengths designated by the API inspector. You got to reference API 510, 742, and 743 for evaluation of thinning, plate, and pitting. So if you come across some thin plates and stuff, you have some go, no go kind of directions here. So during a current inspection, widely scattered pits may be ignored as long as the following are true. The remaining thickness below the pit is greater than 1/2 of the required thickness. So 1/2 of T required, okay, which would be a calculated thickness based on the pressure and anything, maybe structural, whatever. The total area of the pitting that is deeper than the corrosion allowance does not exceed 7 square inches in any 8-inch diameter circle. The sum of the pit dimensions that is deeper than the corrosion allowance along any straight 8-inch line does not exceed 2 inches. So what they're saying is, if you're outside of these parameters, you can ignore it. You don't have to worry about it. You don't have to evaluate it. But if they don't pass 1 or 2 of these, then you have to go to these next steps here to evaluate it. So evaluation of a locally thinned area. For a corroded area of considerable size, the wall thickness may be averaged over a length not exceeding the following. For vessels of inside diameters less than or equal to 60 inches, 1/2 of the vessel diameter, or 20 inches, whichever is less. If it's greater than 60 inches, it's the diameter divided by 3, or 40 inches, whichever is less. Along the designated length, the thickness reading should be equally spaced. So let's say that it was 20 inches, okay? It should be equally spaced. 20 inches, I would go every inch, which means you'd have 21 readings, okay? For areas of considerable size, multiple lines in the corroded area may have to be evaluated to determine which length has the lowest average thickness. Now, we're looking for average thicknesses here, okay, which is inside the corroded area and may extend outside of the corroded area, just whatever the 20 inches goes to. All right, where an area of a vessel is not accessible due to jacketing, especially if internally lined, sampling the cooling water for contamination can be advised. When out of service, the jacket can be hydro-tested to a holding pressure or viewed internally for leaks via the manway or other accessible ports. LPG tanks. LPG tanks, which is liquid petroleum gas, like propane, butane, and pentane, often have underside components, head plates, or shell courses. In the National Board Inspection Code, the NBIC S7, paragraph F785, corrosion, states, general corrosion for a corroded area of considerable size, the thickness along the most damaged area may be averaged over a length not exceeding 10. So for LPG tanks, your length that you're going to take those evenly spaced readings are over 10 inch, as opposed to what we just read at API 510 for the rest of the vessels, which is determined by the size, either 1/2 D or 1/3 D, or 20 inches or 40 inches. The thickness of the thinnest point shall be less than 75% of the required wall thickness, and the average shall not be less than 90% of the required wall thickness. So you can actually do your calculation, and then reduce the calculated T-min by 90%. That gives you a little bit of leeway for corroded areas, for undersized plates, and all that. And this is just specifically for LPG tanks, okay? So all the rest of them go by the 510. LPG tank should be done in accordance with the NBIC National Board Inspection Code. And here's kind of an example. Let me go through this real quick here of how you go about doing that. So you find an area, and it's an area of corrosion of a number size. T2 would be at the lowest point in that area, okay? So again, our criteria for API 510, if it's diameter is less than 60 inches, it would be diameter divided by 2 or 20, whichever is less. And then for the greater than 60, D divided by 3 or 40, whichever is less. And then for LPG tanks, L just equals 10. So you're going to take this area, you're going to draw some lines down it. Let's just look at this from an LPG tank point of view. We're going to draw some lines down through that corroded area at wherever the deepest point is. We're going to make sure we draw a line through that point and make sure that's included as one of the points in that line. And then in this case, we came up with 5 lines. And now what we're going to do is we're going to take readings I recommend every inch for, let's say, for 10 inches or every half inch. The more, the better. It's refined. For the low, for these, I would say 1 inch. Here, you might want to go with every half inch. Okay, so you should have 21 readings when you're done. All right, in each of these areas, a lot of this you have to determine it from nominal minus whatever you get on a pit gauge. But you want to just, you don't have to hit bad spots as you go along. Just do it evenly through there. Well, you do want to hit the lowest spot in each one of these, but then and definitely the lowest in all of it. But just do your readings equally spaced. That's what the code says. So then you're going to determine your T nominal, your T average. You're going to take those 21 readings, let's say, and you're going to get the average of those 21 readings. All right, and then you're going to do a calculation, find out what your T-min is, okay, here, and then you got to determine your T2, your lowest spot in there. Now it's got to pass that criteria. So the T nominal, we'll say in this case is 1.0, T average is 3/4, T-min ½ inch, and your T2, your lowest reading, the remaining thickness is 385. So now we got to go do those evaluations from where we saw before. So we get a T average of 0.750. The T-min is 0.5. So we know that's okay. So this deepest one that we got here, or your average, I'm sorry, your average that we got, even though you have a lower one, but going by average, is greater than your T-min, okay? So then you have your T2, which is your lowest spot. It cannot be greater than 75%, if you remember, for LPG. And the lowest spot is 385. Divide that by the T-min, which is a ½ inch. You're 77. You're above 75. You're okay. So the corroded area is acceptable. Okay, and you can find this both in National Board Inspection Code and 510. Now you got your NDE examinations, you got your mag particle testing, your dye penetrant testing, your wet fluorescent mag, X-ray, long range, ultrasonic pigging, UT shear wave, C-scans, eddy current. These are some of the most common NDEs, and this is something you're going to have to determine before, or even after, say you find something you need to further examine it, you got to determine which one of these would be the best applicable one. Okay, and then now evaluating the results. As your API 510, you would go to 7.1, and there you will find your corrosion rate determination, your remaining life calculations, your maximum allowable working pressure, your fitness for service. So they do a corroded area level 1 fitness for service for 510. And when I say level 1, it's from your 579 fitness for service evaluations, okay? And required thickness determination, and then evaluations of existing equipment with minimal documentation. So sometimes you'll have a vessel, it has no U1 data sheet, it has no data plate. What do? You go to 7.7, it gives you steps to take. And then of course, it gives you an outline for your reports and your records, okay? Then you have, if you have to go to, you've got an area which is outside of the API 510, you might have to go to 579 fitness for service evaluation, okay? You have here for metal loss that exceeds corrosion allowance, which level 1 we do. You'll have done that, but you will also have an option for level 2 and 3. And all these have a level 1s, level 2s, and level 3s. Blistering laminations, weld misalignments, shell distortions, crack-like flaws. Normally, there's no cracks are just not allowed in any form, other than there are pieces of equipment. For example, the cokers are allowed to have cracks with a limited length and depth, but that's outside of a 510 inspectors. You got to have a professional to come in to evaluate those. And then, of course, effects of fire and damage. Okay, so a little bit of guidance of how to check it. They set up fire zones, fire zone 1, 2, 3, and then what to check for, depending on what kind of heat that it saw. All right, so now we're going to go to, that was rather quick. I was limited to half hour. So now we're going to go through our demonstration here of the API. Okay, where are we at here? Software, the API toolbox. So you get into the toolbox, you'll come up to a screen like this. Let's go and take a look at API 510. All right, so it brings you up to the base module page. Here you'll have tabs for code bytes, some of the most commonly sought after information about inspecting and repairs for vessels. So you have PV. Most pressure vessels are designed to ASME, and then here's some of the types of corrosion, so you can get a real quick answer to what types of corrosion you're looking for and what to look for those different types of corrosion. This is for inspection evaluation, what we just went over, how to determine certain corroded areas, level 1 T-min and all that. Safe entry, hydro testing, repair and alterations, re-rating, record, certifications, pressure relief, and in minimum sign metal temperature. So you can get some quick answers here, and it will always reference you to where to find these in the code. So if you're not completely satisfied with what you hear, just go to the code and go from there. The big thing here now, of course, is reporting, right in a report. And so that it covers all those requirements of API 510. Okay. What's going on here? Okay. So these open up with tabulated windows every time you open up. If it's not one that you're going to need a reference, you can get rid of it. And you can always open it back up if you need to. All right, so this is what we call the base page for report writing, for doing analysis of all that data. Just come in here, you have a lot of drop downs to help you figure out what goes in here. So a lot of this is just your basic data, the inspector, insert number, employer, client, diameter. Now some of this cascades for information cascades for your inside diameters, your age. This is for an age. This is not for a date, but for how old it is. Okay. Codes, construction code. This was one of those we didn't know because it didn't have a data plate or U1. Material type, board, not national board number. I just threw some of this information in here just for the sample here. Maximum allowable working pressure will cascade forward. Your design temperature will cascade forward. All of your thicknesses of your components will cascade forward. In this case, I show an example of, hey, you have two compartments here that you can use. Normally we just use this one here for the main vessel, which all this information here is going to be connected to. But if you have a second chamber, like you have a heat exchanger or a tower, or in a case where you have a corroded area, okay, you can actually isolate that corroded area and that information that needs to go here in regards to that particular area, so you can evaluate that apart from the rest of the equipment, rest of the components. You have a cover text here, and you always want to either put your own. You can always have your own, that if you don't feel like this is appropriate for yours, Or you could use this one, and this one basically, if you start a brand new one, will automatically fill in a lot of this information, the company, the date, and all that. But if you copy, but you have the option of starting new, you have the option of copying, you can just come in and, especially if you're doing multiple reports, just change maybe just the pressure vessel name. If they were all inspected in the same facility on the same date, that's all you need to do. And then always make sure, of course, that you hit save. All right. Then what you can do once you get all this filled in, get your cover image in there. You can upload your cover image and all that. You can get a description and all that. On this page here, if you want to kind of see what, because sometimes these doesn't come out exactly the way you want them, so you can rearrange them. The best thing to do at this point is just take a look and see what it's going to look like. So here's the first 4 pages of the report. Okay. You can also check, make sure your verbiage is right, that you covered everything on your text. Here's your table of contents, and then here's your executive summary. In this case, we didn't have no documentation, so I gave them actually verbatim from the code, what the code says to do with that. There is a summary table, has your nominal design, actual, minimum required, your design maximum allowable working pressure, your calculated maximum allowable working pressure, and your remaining life. So it will evaluate all that. You won't see this at this point until you filled in all the rest of the data, but this will give you at least what the cover page looks like in your table of contents and all that. All right, so then you want to go to your appendix, and then each of these you have some defaults that this will default to, like your component thickness measurements, your for appendix A, appendix B, your mechanical depth. So this has all your calculations, and you can take away from these. I would say if you want to take this one away, but you need to up what was below it. Okay, so you would take and put that there and take this one away. See that? So to keep them equally spaced in the table of contents. But in this case, we are going to look at all this. And as you saw in that picture, this is a horizontal tank. So now I need an extra calc that doesn't default, and that's my horizontal calcs. Okay, because you definitely want to do for a pressure vessel the horizontal calcs. You cannot just go with the 510 pressure retaining calculations. You would want to do a horizontal tank. You got drawings, and usually that's done in AutoCAD, and then you upload it here. You have your checklist. You go in there and do your checklist. Hopefully you use the forms from the program. The program has forms for all these for the field. You use those, they go right straight in here, physically, not electronically. Although we do have some electronic software that you can do that, and that's going to be shown here in a little bit. Photos, U1 manufacturer sheet, engineering drawings. If you don't have those, just delete them. You can either, if you don't have either of them, just unclick this and it won't be a part, and it'll shift your appendices. And then you have your NDE records. That will be your UT Cal records, your NDE technician certs, and your API certs. And all this is based on API 510 criteria for inspection. All these elements should be in your report, and it will reduce your kickbacks from the client by 90%. I'm telling you, getting your bases covered. Then you have your write-up, okay? And the write-ups are separated. Here's what I found. Here's my recommendation. So they're right next to each other. And they are also separated in the report. You'll have this as 1 page or 2, and then this is 1 page or 2. I've had a lot of feedback from OSHA audits that they love it. It's just like, you don't have to hear the crying, just see the baby when it comes to what maintenance needs to do with each of these subjects here, titles. And then you have the executive summary. Normally I don't put everything in here, coding, chip coding, this kind of stuff, but I will put in any exceptional stuff, anything that's going to prevent it from being closed up and back into service, any major NDE that was performed outside of VT and UT, you know, anything that's got a price tag on it, I would put it in here, okay? All right, so there's basically the rundown on the report. 8x570 is basically exactly the same. It's the same formatting, the same appendices, listings, and the write-ups and all that. So, and finally, let's just take a look at what a report will kind of look like. It takes a little bit to go through the reporting um, mechanisms algorithms that it has here. We've got a lot of feedback on the reports. Most clients really love them. They're straight to the point. There's not a lot of redundancy to them, and they're very homogeneous. So it's like I say, using this report and using all of the aspects and the elements of it will reduce kickbacks from your clients quite a bit. That was one of my motivations when I initially developed this program, is to, you know, look at where the kickbacks are coming from. Say, how can we make a program that will do a report that will be acceptable? It's not going to be acceptable to everybody, but if you can reduce it by 90%, that's a great margin there. Oh boy, oh boy, oh boy. All right, so we have a little problem with this one here, and usually that's because I uploaded something in the dependencies that he doesn't like. But let me see. Okay, so anyway, the report is something that we can always give you samples of. Let me see if I can go real quickly to get a nice report here. Let's see. Let's go here. Let's go here, and let's go here. All right. So here's kind of what a report would look like. You got your logo for your company, the company that you did the work for. You can have a choice to put on a overall picture of it or not. It's up to you. Okay, your table of contents, your executive summary. There's a little table showing all kinds of information that may be where, you know, what somebody's looking for, so they don't have to read the whole report. Matter of fact, this should give you an overall evaluation that's why it's called executive summary. Then you got your data concerning that in regards to that. And different here, we had an issue with head 2 plate being thin, called it out. There's your write-up, and we broke it down to foundation, shell heads, appurtenances. There's your recommendations. Again, per your individual items, and then your next inspections and anything that's hindering the remaining life or detrimental to the remaining life. There's your UT results. Okay. Component measurements. So you got the component measurements for your shell, your head 1, head 2. This was an LPG tank. And then you got your calculations for your cylindrical shell, your formed heads, and your horizontal tank calcs. Here's your shell calc. Here you're determining 18 men. Here you're determining you can determine your remaining corrosion allowance, your corrosion rate, and your remaining life based on these values that we determined as we were developing the report. And here's your maximum allowable working pressure. This thing's rated for 250, and as you can see, this can be operated. This has a maximum allowable working pressure above that, and you can't change it, but it shows it is safe to operate at 250 psi. Same thing with all these components. Now, remember we said that this one plate, this one head, the south head had plate 4 that was kind of thin, so we evaluated that individual from the north and south head as a whole. All right, and we came up with a couple different T-mins here. T-min 465, 465, and 419. These heads Trying to think of what the difference is here. I think what we're going with here is because this is allowed by the NBC code to go 90% of the T-min. So the T-min's here. I think if you calculate it, you'll find that's 90%. That's why we went with 419, because that's how the code says to evaluate it. Okay. So that gives you a remaining life greater 20 years, greater than 20 years, greater than 20 years. Maximum allowable is 255, 250, and 250. And this one here is a user input value, because if you calculated this, reversing the calculation here, it would actually be below that. But the code says you can operate it at 250. Okay. And here's your horizontal calcs. This one you'd probably need some training on it a little bit, although all the parameters are pretty much can be found within the program itself. So, all right. And then you got your drawings, CAD drawings, maybe your checklist, your photos, and then your U1 data sheet, and then your NDE records. Okay. All right. And like I said, 510 is 570 is pretty much the same. Okay. So that's the end of the demo.
Awesome. Thank you so much, Jeff. Before we get to the poll questions and Q&A here, I'd like to show a quick preview of our app that we've been working on. If you attended our webinar a few months ago, that when we covered API 653, you would have seen a quick preview of this. We are obviously a lot further down in development now. We have API 653 available, 510 and 570 are coming very shortly. So I just want to show you this quick preview of our in-field data collection app. That's just a quick preview of the app that we have. So without Wi-Fi in the field, we've gotten a lot of comments asking, for something available on a smartphone or a tablet. This app is available there. We would love more people to help us beta test this and give feedback on it. So our first poll question is related to that. So this API collector app, if we can go ahead and show the poll questions. So this API collector app allows you to switch between multiple reports. You can pick and choose which you'd like to revise and edit. You have the option to also create a new one. You have the unlimited amount of reports available. As you saw, you have access to those forms in the field that Jeff mentioned, also available within our software. And then you have everything you need will be collected on that base page, same as in the software as Jeff showed. We have the write-up section and the report appendix options all there in the app available for you to use in the field without that Wi-Fi access. Then you have unlimited CML rows during your inspection. You can instantly upload images and add notes or captions to those. And then it also has those comprehensive checklists, as you saw. It's really easy to quickly hit save for the report and then upload it directly into the software for either further editing or if you choose to export it then to a Word doc or a PDF, as Jeff showed you. So giving you that final report that he showed. So that's just our first poll question. We're always looking to improve at technical toolboxes. So these questions kind of help gauge your interest in not only the API Collector app, but also our API Inspectors Toolbox software that Jeff just demoed in the Pipeline Hub. So we'll leave this question up just for 1 minute longer. I'd also like to, after you answer that poll question, remind you that in the right-hand interface of GoToWebinar, we have a handout available to you if you're interested in our software. It gives the one-pager to our API toolbox that we have available in our software that was demoed today. Again, we have 653, 510, and 570 available within that toolbox. So that is the one-pager kind of to give you some more information there. Just a reminder, please submit any questions that you have for Jeff or Paying Cash, who is in our engineering department, that will also be available to answer questions related to the software. Looks like we have some good questions coming in, so we'll get to those as soon as this poll question wraps.
Is this to me?
Hey, Jeff. So no, yes, we'll go ahead and display that that last slide, but I'm going to start building some of these questions to you in Paying Cash now. You might need to show the software depending on the question. So let me get these organized here. Let's see. So we've got a couple questions here. This one I believe is directed towards you, Jeff. If you find laminations in the shell, how do you evaluate that?
Do I have the screen?
Yes, we can give you access, absolutely.
Okay. Let me know when I got it.
You have access.
Okay. So if you could, it's funny you asked that question because I just did a tank that had a bunch of lamination in it, so I had to put this little together. So perfect timing for that. Can you see this about the FFS forum laminations? Can you see my?
I did not see your screen yet. You might have to allow it.
Oh, screen.
Yes, you'll have to select that option. There you go. Now we see it.
All right, so I'm not going to go into what a lamination is. It's just during fabrication, sometimes you get these inclusions that get squashed out into the metal. And of course, your UT meter is going to stop right where that lamination is. A lot of times it's close to halfway through it. But let me just read you what you can do when you find the laminations is go to, you need to go to your 579, look up for laminations. It's under 7422. And let me just read this here for a level 1. A lamination is acceptable regardless of size if all of the following are satisfied. The component is not operating in a hydrogen charged surface because it will fill up that void and make it a blister and rip it open in time. The distance from the edge of the lamination to a major structural discontinuity, such as a weld, is greater than or equal to 1.8 times the square root of D times T. That's actually, I think, divided by here. No, what's the time? Okay. Times nominal, where D and T is defined in paragraph so-and-so, which we have down here. D is the shell inside diameter, and T nominal is the wall thickness. So I got 2 examples here. So here's one that has a diameter of 111. It has a thickness of 1 inch. And then you do the calculation and you come up with 18.96. So what this is saying is that lamination is okay as long as it's greater than this distance from any discontinuity, like a weld. Okay, and this is a pretty big tank. Normally we've got smaller tanks. Here's a 48-inch tank. It has a 375-inch wall thickness, and you do the calculations, and it cannot be no closer to a discontinuity than 7.64. So that's how you evaluate at a level 1. Level 2, you can reduce it to a, well, let me just read it. If the distance between the edge of the lamination, say it fails this, you might have to go to level 2. If the distance between the edge of the lamination and the nearest weld seam is less than 1 inch or twice the nominal thickness, whichever is greater, then the same provision is as detailed in paragraph so-and-so for blisters applies. to ensure that through thickness cracking does not occur. So basically the difference is you've got a calculated distance it has to be. If it's within that, then you can go to 1 inch, but then you're going to have to monitor it during in-service inspections. So that's the difference between level 1 and level 2. So that's the two options that you have, well, for evaluations, but you also have, you can cut out that area, put in an insert and that kind of thing. So that's how you would handle the lamination.
Thank you, Jeff. A couple more good questions coming in here. So the first one it's basically two parts. So does your platform have a library of all the allowable stress tables from different years for the T-min calculation? Allowable stress values may change through the years for the same material grade. This may be a question for PK as well.
Well, that's can be easily answered. Yes, it does. Depending on, because the stress values might change between what year, before 99 or after 99, and the temperature. So for all the basic material, not everything in the SME, but pretty much anything you're going to have to do within this industry is in there. Yes, you have it. It automatically fills in when you're doing the calculation. You just select the material, and then depending on when it was built and what temperature it runs at, it will automatically put the correct stress value for you.
Perfect. Can you clarify what 579 excludes? I am interpreting that it does not allow you to exclude cracks and things like tank floors or welds.
To exclude, again, cracks pretty much are unacceptable on any level, except there are some vessels that it's actually acceptable for cracks, and so it's not excluded. It definitely can do an evaluation on those. I can't tell you every situation that it might be excluded, but it pretty much covers most anything you come across. It will deal with it. It will give you level 1, 2, and 3 evaluations for that.
Great. Here's another one for you, Jeff. Does it have the ability to perform external pressure vacuum calcs?
Yes, absolutely. Yep. Just exactly in accordance with ASME Section 8, Division 1.
That's pretty straightforward. Awesome. Okay. So does your program handle short-term and long-term corrosion rates?
It does. It doesn't do it naturally. You'll have to do some pull downs into Appendix B to do a specific CML location. You also can use a couple other different calculations that we have in there to do that. Yes.
Great. Please continue to submit your questions. We have another 10 minutes, so we can try to get to all of these. Any questions, please submit those in the toolbar there. Next question for you, Jeff. What if you find areas in the piping where the actual thickness is below the practical T-mins in your program?
Okay, well, obviously you're talking about API 570. Those practical T-mins are given in 570, and they're just saying that, you know, these. Let me go to 570. Are giving in each and every organization has to determine their own. I've been in several different organizations, and I have determined that what I feel like is the best fit for normal carbon steel piping, but you can always do the defaults in here. Let me see if this comes in here. The defaults in here. See, here. Let me go back here. Did I? Not sure what happened there, but here are our practical T-mins for piping, and they're for carbon steel pipe. These you can change these here. If you have a different set of values, you can change these right here, and it'll go cascade through the program. If you're doing you find an area that's lower than that, then all you have to do is, these things are normally default here. I'm not sure why this is not defaulting here, but normally you get a remaining life calc, a pressure calc, and a pipe support calc. And what this does, of course, this will do your pressure calculation. And those are usually so small, they're not even hardly worth, there's no way you can let them that small just because of structural. Somebody steps on it and breaks it if it's too thin. That's how thin some of these calculate to. But you do that calc, and then you do your pipe support calc, and that is just doing your bending moments from one support to another. Let's say you got 20 feet there, it will calculate based on the weight of that pipe, the thin as it can be to support the pipe from. So you do those calcs, and you put in maybe a little bit of more, leave a little bit of more for corrosion round, because you're going to need. Because at that point, that's a flag to say, hey, I need to replace that, but hey, I need to make it to 6 months and a year from now when the turnaround comes up. So that's what you're after. So you can determine between these two, and I always do it in superposition. I add the two together and say, okay, my T-men here was a 4-inch pipe is 0.1, but I got a 0.07. And I just calculated it, and I'm allowed a 0.06 to handle all those different variables. Then you can reduce that to 0.6, and you can also do that in the program itself individually for each CML. All right, and that way it gives you the remaining life to make it to that next turnaround. So yes, you can do that.
Great, thank you for showing that. Here's another one from Sean. Does your system have the ability to communicate with an IDMS software such as UltraPipe or PCMS? And we might need to, PK may be able to answer this as well.
Yeah, I'll answer that one. Thanks, Cassidy. So as such, there is no straightforward integration with the other tools. However, we can write the scripts. If you have your data, you want to bring it in. We can coordinate with your team and design that script so that the data can be imported here. But there is a mapping piece that we have to do. So it's basically, we have to work with the team who is trying to bring in the data here, but that can be done.
Well, you could also set up your boilerplate in your DMS to have the same rows and columns. So that when you're taking your readings, as long as they're the same rows and columns, that we have a template, an Excel spreadsheet, you can just copy and paste them right into that Excel spreadsheet and just bring them right on in. That easy. But you got to set up your boilerplate with the columns and the rows the same as that template.
All right, thank you.
Thank you. Thank you. Okay, I think we can get to a couple more here. Were the lamination acceptance criteria located in your library?
I'm sorry, repeat that.
Was the lamination acceptance criteria located in our library?
No. That was from the 579. I was, like I said, I just recently ran into this. I had to look this stuff up for that client. So you're gonna have to go to 579 to get that, but that's where this criteria comes from verbatim.
And I'll add a little to that. We do have in the plan to add 579 to our API inspectors toolbox. So that is definitely something coming in the future at Technical Toolboxes, because it is become of interest to a lot of people that we have as users. Okay, here we go. Does your program offer anything on welding?
Yeah, yes, it does. As a matter of fact, you got a whole repertoire of welding. Let's see, let me get into it. It's under 510, and let me get there. So it's a handy little pages for that. So right here we got visual inspections, kind of a little code bytes for that, talking about the different types of welds and all that, visual inspections. And okay, that's all one. So you got your ratings, your RT ratings, the different for the different categories, category A, category B, and all that for that. And then you can have the description of how each one of those things are evaluated for category A and D and all that, and what they're here's your table UW12, which gives you all the different joint categories. It's category 1, and you look at A, B, C, and D joints and what their degree of radio exam will give you for full, spot, and none. Okay. RT, there's a lot of your ratings you'll see on the data plates. RT1, what that means, RT2, RT3, RT4, there's a definition of what that covers for what welds they did. Then you have your typical weld joint. So here's a bunch of different weld joints that you'll run into out there for piping and for the pressure vessels and storage tanks. Butt welds, lap welds, all that kind of stuff. Let's see, I think that's all that's there. Weld symbols. I know a lot of times we forget what our weld symbols are. There you go. All the different types of joints, their weld symbols, and all of that. We have NDE testing for that, weld procedure certification. There's also, let me see where that is. Oh, it's down here. Okay, cancel that. So down here, weld rods. If you want to know about weld rod, here's SMAW, the most common welding rod there is. Look at this. Let's pick something out here. Let's say it's a stainless steel 304, and I want to, so that's my base metal, and I want to weld it to a 410. There's my weld rod, my preferred weld rod. There's also an alternate weld rod right there. Okay, so it gives you that. You can look up that weld rod here, and it'll give you everything you want to know for an AWS class A number, what it's used for normally, and the USN number, and what's a chemical composition is, and its tensile stress. So yeah, you got everything real here. So let's see, and your PQ to review PQRs, WPQs. It gives you a little platform to go through and fill it in and see whether their procedure is acceptable within code and all that. So yeah, I think we've got just about everything you need for welding here.
Absolutely. So we have PK on here. He answered a question earlier, but he does want to point out one new feature that we have since our last API focused webinar. PK?
Yes, so I wanted to mention that we have the capability as well within the program that if the reports are getting created within the same group, those reports would be visible to everyone in that same group, but they won't be able to edit it, which is done knowingly to avoid any kind of data corruption. But having said that, that feature is currently also being built, wherein users would be allowed to transfer the ownership of the files itself, so that at single point, one person would be able to edit that report, and then others would still be able to see that one. So that feature is there. So collaborative feature we have, and then the ownership transfer is being built into, so that will be released very soon. So there are few other platform specific things wherein if later on, let's say someone from your company, he leaves, and the data that he created, actually it would still be visible in there, and that can be transferred to any other user who would join in or who would be willing to take ownership of those reports. So just wanted to mention that one about the platform specific feature that we have.
Absolutely. And it also works really well for an operator and say a third-party service provider that want to share reports and collaborate on those. So it's a great new feature we've added. That's all the questions we've got. There might be some that come in here last minute, and we will answer those via email following the webinar. But this recording of the webinar will be available on our YouTube channel in the next couple of days, as well as everyone that registered and attended will receive an email in the next day with the recording and also that handout that I mentioned earlier that's attached. So thank you all for attending, and to everyone that submitted questions. Thank you again to Jeff Walling for the presentation, and for PK with the assist on some of the questions and the features we have available in the Pipeline Hub. We hope you all have a great day, and we appreciate you attending. Thank you so much.
Thank you.